So the trace of a matrix is simply the sum of its diagonal. So the trace of this matrix over here on the left is going to be 6 plus 6, it's 12. The trace of the matrix on the right is going to be 3 plus 8 plus 15, it's going to be 26. The determinant is a useful number that tells you a lot about a matrix. So for example, if the determinant of a matrix A is 0, A is not going to be invertible. If we have a row of zeros in a matrix, then the determinant of A is going to be 0. It's a property of square matrices only, and we're going to discuss this down below. Finding determinants. A 2 by 2 determinant is very simple. We're just going to multiply in an X shape across this matrix. So we're going to have AD, and then we're going to subtract BC. AD minus BC. Okay, so the 3 by 3 determinant. So there's a number of ways of doing this. So we're going to have the product of a diagonal of a triangular matrix. We could use cofactor expansion along a row or a column. And my own preferred way for finding the determinant of a 3 by 3 matrix is this diagram here below. So what we're going to do is, if we have a matrix A, B, C all the way through K, we're going to place A, B, D, E, G, H here, the first two columns. In doing so, we're going to write plus above the first 3 here and minus below the first 3 on the bottom. Doing that, we draw our diagonals along here. There are positives, and then we draw our diagonals along here. There are negatives. So the determinant is going to be given by A times E times K along here. Gives us this, plus B times F times G here, plus C times D times H here, and then subtract away GEC, subtract away HFA, and subtract away KDB. That's your determinant. So the next method I want to discuss is the cofactor expansion method. Cofactor expansion method involves the sign matrix. So A11 is going to give you 1 plus 1. That's even, so we're going to have a plus. A12 gives you an odd number, so that's going to give us a minus. So on A13 gives a plus, that's an... Why is that? So we get that from this matrix down here. Minus 1 to the power of the sum of the row and the column components. So we can call that minus 1 to the power of I plus j. Now, a minor is the determinant of the n minus 1 times n minus 1 matrix produced by removing some row and some column. So, the expansion of the n by n matrix along row 1 is going to be A11 times C11 plus A12 times C12 plus A13 times C13. So C11, C12, C13, blah 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 are cofactors. So they're the product of the corresponding sign and the minor for that particular component. So for example, 4 by 4 cofactor matrix is going to be plus big M11 minus big M12 plus minus and so on. Let's have a look at this matrix here. This matrix is 1, 1, 1, 1, 3, 9, 1, 4, 16. We've dealt with this before. Over here, this here is the sign matrix for that particular matrix. The minor here, 3, 9, 4, 16. We're going to find the determinant of this. The determinant of that is 3 times 16 minus 9 times 4. That's going to give us 12. M12, so we're going to remove row 1 and column 2. We're left with a matrix 1, 1, 9, 16 here. 1 times 16 minus 9 times 1 is going to give you 5. Again, minor 1, 3, remove first row, third column. In doing so, we're going to get a matrix 1, 4, 3, 1. So we're going to go 1 times 4 minus 3 times 1. We're going to have determinant of 1. Now, M11 is going to be 12 times positive 1. So minus 1 to the 1 plus 1 is going to be 1. 5 to the M12 is going to be minus 5 because we have minus 1 to the 1 plus 2 is 3. Minus 1 to the 3 is minus 1 times 5. C13 is going to be 1 then because we have 1 times 1. C13 is then going to be 1 times minus 1 to the 1 plus 3. It's going to be 1 times 1. Now, the determinant of A is going to be A11 plus A12 plus A13. The dot product of that with C11 plus C12 plus C13. So we have 1 times 12 plus 1 times minus 5 plus 1 times 1. The determinant of this is going to be 12 minus 5 plus 1 is 8. If we perform this along the second column as opposed to the first row, we're going to have the determinant of A is A12, so the A12 component, 1, plus A22 is just 3, and A32 is 4, multiplied by C12, this one here, this is the sign of it, plus C22 plus C232. So how are we going to get these? So we find minor 1, 2 by removing the first row and the second column, and we're going to keep removing the second column each time. We're going to have 1 times 16 minus 9 times 1. We're going to have a determinant of 5. Here, M22, we're going to remove the second row and the second column. We have a matrix 1 times 16 minus 1. We're going to get a determinant of 15. M32, we're going to remove the third row, second column. We're left with a matrix 1 times 9 minus 1. There's the determinant of 8. Okay, so our cofactors are going to be given by the product of these determinants with the corresponding sign. So C12 is going to be minus 5. So minus 1 to the power of 1 plus 2 times the determinant. C equals minus 1 I plus j times the corresponding minor. So we have then C22. So C22 is going to be given by this here. Minus 1 to the 2 plus 2 is plus 1, so we just have 15. C32. So 3 plus 2 adds to 5, so that's going to be minus 1 times M32, which is going to be minus 8. So taking the product of C12 with A12, we're going to get minus 5. Taking the product of C22 with A22, we're going to get 15 times 3, which is 45, and C32, which is minus 8, multiplied by A32, which is 4, we're going to get minus 32. Sum that all up, gets to 8.